Okay, and for example, they say, okay, you derive e to the power 2x. Okay. So when deriving a, remember, you write the same expression as it is. You keep it the same. Okay. Then, after you've written the same expression, then you derive the exponent. So, colleagues, if we derive 2x, what did we get? When we derive 2x, what did we get? The Easter holiday. Were we studying during the Easter holiday, colleagues? Did we study? Madam Wansa, if we derive 2x, what do we get? Thank you. Yes, 2. So your answer, you can leave it like this, or you can rearrange it and you write 2e to the power 2x. Any questions? Okay. So this one, okay, where are you getting the answers for this e to the power 2x? We're deriving e to the power 2x. So if you can see on top the process of deriving e, you write the expression, the same expression you are given, then you derive the power. So remember 2x, remember it's 2x to the power 1. 1 times 2, that is 2. Subtract a 1 from the exponent, x to the power 0. X to the power 0 is the same as 1 according to laws of indices, so our answer is just 2. Is that okay, Mr. Peter? Oh, you have to, if the natural log is the exponent, then you have to derive the natural log, not the e. You never see, oh, you're talking about when it comes like this natural log of e. I've never seen a question like that, madam. Oh, okay. So I have to show you how to derive natural logs, then I'll give an example there. Yeah. Yes. That one is for deriving natural logs. We'll come to it, okay? Yes, yes, yes. Okay. We've got our next one here. E 2x squared minus e to the power 2x squared minus 1. We derive it. So, as I said, you write your expression the same way it is, e to the power 2x squared minus 1. Okay. Then you derive the exponent now, 2x squared minus 1. Okay. Colleagues, when we derive this exponent, what do we get? So you derive the 2x squared and you derive this 1. So when you first, let's derive 2x squared. When we derive 2x squared, what do we get? Yes. And that is your answer. If you want, you can rearrange it and you say 4x e to the power 2x squared minus 1. Any questions? No, we have just brought the 4x in front, and it's this same expression here that we got on top. I've just rearranged it. Yes, you have to put it in a nice format. You have to make the marker feel nice. The way it is on top, yeah, it's still a correct answer. It's just that we just want to put it in a nice format. Okay. Okay. Now we can look at deriving natural logs. Since I'm using u here, you have to put u, not x. So here, let me also just put a u there. Du. So even here, dy du. Yeah, so the derivative of a natural log. So you derive the expression that you are given. Okay, this in this u here, you derive it on top. Then at the bottom, this expression, you leave it the way it is. Okay. Case in point, we start small. Say the derivative, derive the natural log of x squared. So in the numerator, we derive this x squared. When we derive x squared, what do we get? We have to derive this here in the numerator. Then in the denominator, you leave it the way it is here. So when we derive x squared, what do we get? 2x, yes. And we can simplify this further, all right? Since we have an x squared at the bottom, we can cancel out 1x. So our answer remains 2 over x. Okay, next one, we derive the natural log of e to the power x. Okay, so remember, it will be a fraction. This e to the power x, we need to derive it on the top. Then at the bottom, we write it the same way as it is. Okay, so when we derive e to the power x, what do we get? Look at the previous example here. Mm-mm. Almost close. Let me put it this side here. So when we derive e to the, or let me put it here, e to the power x. You write the expression as it is. Then what's the derivative of x? 1 over xe. When we derive e to the power x, remember we write e to the power x, we write the expression. Then when we derive x, when you derive x, you get 1. Are we okay with that, colleagues? When you derive e, just look here, look here on the left hand side. When we're deriving e to the power x, first you write the expression e to the power x. Then now you derive this x. When you derive x, what do you get? You get 1, right? Okay. Okay, look, sir, just the way I was deriving here. Look at these previous examples. Have you seen? In front. You- No, it's not going to be E1. It will just be it will just be EX. If you multiply EX times 1, it's just EX. Mm. We've, der- we've derived we've derived this X, this power X. Okay. When you derive X, remember X to the power 1, this 1 times 1, you bring this 1 in front here. You subtract a 1, you remain with 1, X to the power 0. And this X to the power 0, it disappears. That's how the 1 is coming about, sir. We have just derived this exponent here. And that's how we've got this 1 here. Mhm. so that we see everything that is happening. Because if I wanted, I don't even need to show this one. I just leave it like this. I just wanted to show you that I derived this x, the e. Remember, when we're deriving, just ask again. The x will what? Madam, the x will be there, madam. Refer to the left hand side, madam. Have you seen how we're deriving e earlier on? Yes. So when we're deriving e to the power x, the first thing you write is this e to the power x. Then you derive this power x here. When you derive this power x, madam, that's how you remain with the 1. Yes. Okay, first let me finish this example. We try another similar to this one. We try another example similar. Maybe the x deriving it has made things tricky here. But okay, let's look at this. Let's look at this example down. Then we'll relate it to the one on top. Natural log e to the power x squared. Okay, you want to see numbers now. Okay, natural log the e to the power x squared. So, as I said, the original expression you put it in the denominator. Okay, e to the power x squared. Then now we derive this e to the power x squared. So let me put this side e to the power x squared here. So colleagues, when we're deriving e, we write the expression as it is, we repeat it. Then we derive this x squared. When we derive x squared, what do we get? 2x, yes. So here we write 2x e to the power x squared. So the one on top, because it was, we had a 1. Okay, where were you a bit lost? The deriving of e. No, it's okay, sir. The purpose is to learn here. I hope your screen is holding. Yeah, I hope it's you're able to see now clearly. Yes, as I said. Okay. As I said, when you're deriving e, okay, first thing you do is you write the expression as it is. Listen, this e to the power x squared. I've written it as it is here, e to the power x squared. Is that okay, sir? You first repeat the expression. Whatever expression you are given, just repeat it. Then after you repeat the expression, you then derive the power. Okay, you focus now on the power and say, okay, now I need to derive x squared. Okay. So you remember how to derive x squared, or do I need to illustrate it? Okay. So x squared, remember the principle of differentiation, the exponent multiply with the coefficient. Here the coefficient of x is 1. Uh-huh. Yes, the coefficient is just a number before a letter. So 2 times 1, that is 2. Then the same exponent, sir, you subtract a 1 from it. 2 minus 1, that is x to the power 1. Okay, so sir, that's how we've arrived from x squared when we derive it to come to 2x. Okay, sir, that's how we came with to 2x. Any questions? Okay, any other questions? The derivative of x, right? You mean when you derive x, it equals, yes. Like here in this example here, when we derived e to the power x, here on the numerator, we wrote the expression as it is, we derived x, that's why we brought a 1 in front there. This 1 is the derivative of this x, this power x here. And in this case here, for this example, this 2x is the derivative of x squared. Wonderful. Wonderful. Yeah, at least even though one person gets it, I even get happy. Hooray! Colleagues, questions? Because it's getting, this is just surface level. This is just surface level. This is just, it's grade 12. This is just grade 12 here. We haven't yet entered university. Eh? We haven't. mm, I'm even afraid to bring this one with this car root, this one with the root, because when these roots come, yeah, it's, when the root comes, it's game over. So please, colleagues, hang on tight. Here, the secret is this, colleagues. Just write down the rule first, because if you don't write this rule down, every time I'm deriving, you just get confused. Okay, write the rules down here. Okay, for natural log, in simple words, when you derive a natural log, your answer is a fraction. With that fraction, your numerator is the derivative. The numerator is the derivative of whatever expression you're given, and then your denominator is just the same expression. Okay, have you seen the denominators in this case for these questions? It's just the same expression. Okay, then the numerator, that's where you do the deriving. Okay, so okay, any questions? Let me first try to start posing questions for us to try to start answering.